Hello and welcome back to Beginning iOS Development. My name is Alex Ackerman, and in this third video lesson I'm going to go over Interface Builder Fundamentals. So what we're going to be looking at in this tutorial is how to use Interface Builder with an Xcode project, as well as adding UI kit objects to the interface and linking that up with your project. And after that we'll be looking at what exactly is a zib, and then how you can build an application without the need for Interface Builder at all. So, getting stuck right into it, let's have a look at Interface Builder. And then I'm going to open up the main view controller zib. And as you would have seen in the previous lesson, if you've been following along in the series, this is Interface Builder, and it allows you to add particular UI kit objects to your UI view. So looking at the windows that we have available here, we have the library window, which shows us all the UI kit objects available in the SDK. We have our window, or as Mark calls it, the canvas. A document window, which will show you a hierarchy of objects that you put onto your view. And then the attributes for the selected item in the document here. So this is the library pane. It houses all of the UI kit objects that we can use in that interface, and it's separated up into a few different sections. And I'll just start at the top with the controllers. These extend particular UI kit objects such as the UI navigation bar and the UI tab bar, the UI table view, by extending them by adding extra functionality, allowing you to easily create views that have subviews and allowing them to transition to a new subview. So what I mean there is, in an application you would have used on your iOS device, you have a UI navigation controller which will have that bar at the top with the back button. If you've just gone into a different data set, so you've clicked on a button or you clicked on a table row and it's taken you to a new window by that sliding motion to the left, the UI navigation controller handles having that back button as well as the title at the top. And the tab bar controller is similar. It allows you to have several child UI view controllers while showing the icons and text down the bottom. The table view controller is slightly different. It controls the data source and delegate methods around a table view. So what I mean by that is you link up your code as a data source to the UI table view controller, and the table will ask for particular rows when requested, and you can pass it the data that it needs. It also has delegate methods, so when someone clicks on a table cell, it will then call on the delegate, which is your code that is attached to this controller, saying, hey, when you need to call a function saying, hey, you've clicked on a button, you call this class. So that's how that works. It'll be explained in a later video lesson. And then the UI image picker controller is quite self-explanatory. It allows you to have the image picking functionality you would have seen in the Photos app on the iOS. On the iOS. And then here are just two different items for adding in custom NS objects. That's obviously something custom. It's not something you do every day in iOS development. Now looking at the data views section. This section allows you to display data back to the user in several different forms. We have a table view, an image view, web view, map view, text view, an iAd banner, a scroll view, picker view, and date picker. These are obviously all used in different situations, so a table view would be displaying a table, of course, and a table view cell is a singular cell within a table view. So if you want to have a custom cell over your whole entire table, or a custom cell for a particular place, you would define a custom UI table view cell. We'll talk about that in just a little bit, possibly in a later video tutorial. Then we have an image view, which allows you to click and drag and bring in a box, which allows you to place an image on the inside. So you can select an image here that's in your project. I don't have any at the moment, but if I had one, I'd select it there. Then UI web view, which allows you to put an instance of a WebKit browser inside your application. It's completely chromeless, so you won't get the bar at the top or at the bottom. It just allows you to have a web browser straight in your application without having the actual web browser. Map view is pretty self-explanatory. It allows you to have the Google Maps placed within inside your application. So you just click and drag that box, and obviously you would add the delegate methods on top of that to be able to control that. Then we have a text view, which is a scrollable text area. Then the Add banner, a scroll view, and it's worth noting that the scroll view is actually used in the text view, map view, web view, and table view cell. The scroll view is actually a subclass of all these objects. So all these objects will have the scroll view to inherit all the scrolling natures by default. And then looking at the picker view, this is the mobile equivalent of a drop-down box on the desktop environment. So this allows you to select particular objects in a set of objects available, and then a date picker is pretty self-explanatory. It's a date picker. And then looking at the next section, we have inputs and values. These are different kinds of tools and controls that the user can interact with that allow them to call on different functionality or call on stuff to happen inside your application. So we have a segment control here, which allows you to have a segmented button set here. So as an example, let's have unread, sent. So that's an example of how you could use this segmented control to show different contexts of information. So you could have a section that shows you unread messages, in this case sent messages or deleted messages. So that's how segmented control works. It just allows you to have a group of buttons that all have the same action but have a different result in content. And they, of course, have different styles. I'll go through this attribute section here in just a little bit. Then we have a label, which allows you to have a non-user editable text field for labels, of course. Then we have a round rect button, which is just a button. You can have different styles. You can have any of these styles you would have seen in applications, as well as a custom one, which allows you to put your own background image on the button, so you can have your own custom button style. Then we have a text field, which is user inputable text. So when the user clicks on that, they'll get their keyboard popping up and they'll be able to edit text inside it. Then we have our UI switch, which is a Boolean switch, allows them to say yes or no on a particular statement. A slider, which allows the user to be able to select a value between minimum and maximum value, which you can change here in the attributes. And then a progress bar that allows you to give the user feedback on progress of something that you are doing in the background. And then that activity view, which is just your general spinner. A page control, which allows you pagination between separate views. This is commonly used on the home screen on the iOS. Just putting this in won't add the functionality of having these separate UI views. You, of course, would have to read out the documentation on how to implement page control inside your application. And then the last section down the bottom has windows, views, and bars. So this allows you to create a new instance of a UI window. Allows you to create another instance of a UI view. It's worth noting that you can actually have UI views within inside UI views, and in fact every object that I have here, including every other object inside this UI kit, is a subclass of UI view. So they all inherit from the UI view. The UI view is the base class. So it has basic functionality around how it scales, its opacity, its background, whether it's opaque or transparent, and stretching and so on. And then the bars available here are all the top and bottom bars available in the application. So you've got a search bar, you've got a search bar controller, which has the delegate methods that allow you to then add your own code around a search bar. So you would have a UI table view controller, and you have a search bar controller as well. So when the search bar is being changed, the table view and the data source get updated. Again, read up on documentation on that. It's very easy to implement, but it's worth having a look at the documentation before you go into it. Then we have separate classes for a navigation bar and all the particular items available in those. So the buttons and the flexible spaces, the tab bar and the tab bar items. It's worth noting that you don't usually add these in separately. So if you wanted a navigation bar and the functionality having the back and forwards buttons, you wouldn't drag these in individually. You would, however, use the UI navigation controller up here and use that instead of just you would use a UI navigation controller and not put in the individual elements yourself. It's not recommended to do it individually because you are recreating a whole bunch of functionality that the iOS has already done for you. We'll go on to controllers in a later video tutorial. So that's all the UIKit objects available. Of course, you can create your own objects using a UI view and extending from that, so you can create your own subclasses of a UI view. So if you want a particular type of interface element, then you could create that and extend from UI view, so you automatically get all this functionality. But again, that's probably something for a later tutorial when we explain how to use subclasses. So what we're going to do for the remainder of this video tutorial is we're going to create a base application similar to the Fortune Crunch tutorial that Mark Hammonds did in the previous video tutorial, but explaining more about IB outlets and actions. So what I'm going to do is I'm just going to drag in a UI label, and I'm also just going to briefly look over the attributes and auto sizing options available in this window over here. So it's pretty self-explanatory for most of these values here. We've got the text available inside the label. So if I change that there, push enter, it'll change over in the UI label over here. So we're setting the value by default for this UI label. Then we can change any of the text characteristics like the baseline, how it handles line breaks. So if the amount of letters or words inside this UI label extends out of the bounds, how it then truncates that, whether it truncates it with an ellipsis or if it truncates it on the start of the sentence, or sorry, on the start of the paragraph or on the end of the paragraph, and how it breaks the words. Then we have your typical centered left aligned, right aligned. How many lines are in the UI label? Typically there's only one, but you can of course change that if you wish. Then we have our font settings. Clicking on that brings up our the typical macOS font window here. Now it's worth noting that there are limited fonts available in the iOS, but using Helvetica is fine. You can use any type of Helvetica, bold, regular, or oblique. They are all available in the iOS. And then we have a setting here, how it handles the font size. We can tell it that when the text extends outside of the label, like so, that actually reduces the font size to a minimum limit. So it'll go down to the minimum size of 10. But if I increase that text, you'll see that it is now truncated using this setting here. So if I go truncate middle, it'll truncate in the middle there. Truncate head will truncate at the start, and so on. But so I'll just change that back. Then we have the text color. We have all the default text colors here, which are also used in other colors, so they're not recommended for text colors, but you can choose any color you want, clicking on other. Then we have the highlighted color state, and then the shadow. So I'm just going to put I'm going to put a white shadow. So we have a white shadow on that, and then enabled whether the field is shown as grayed out or not. Then these settings down the bottom relates to the base UI view class we were talking about earlier. So this setting here is called content mode. This is how, not particularly for the UI label, but when you come to things like adding in an image into a UI image view, you want to say how the image fits inside the particular image view. So you would change these settings here. So if you want the image inside the image view to be scaled to fill the whole entire box, you choose that. If you want it so it fits, so it doesn't overflow any part of the image, you'd say aspect fit, and that would keep the aspect ratio of the actual image. Otherwise you can mix and match any of these and have a play, have a look, see what they do. It's worth noting that it's a good idea to actually have a play inside Interface Builder to bring in certain objects and change the attributes on them to find out exactly how you can use it in your application. Then we have an alpha or opacity setting here, so I can change the opacity of that. Then there's a background color we can choose. A tag is an identifier, so if we don't have an IB outlet for the particular object, we can then call on the tag number to be able to find the object within inside the UI view. Then these settings here, we can say it's opaque, so the background of the object will actually be drawn. So if we say we want the background color to be blue, then the background of this particular object will be drawn, so it won't be see-through. Making an opaque background is actually better in some cases for speeding up an application, but that's something for a later discussion. Whether it's hidden or not, checking hidden here won't hide it, it'll actually just fade it out a little bit. That's purely for representation inside Interface Builder, but it will be hidden on the actual device. And then just a few other settings regarding how the UI view is drawn, stretching, and interaction, whether a person can interact with it or not. So the next thing I'm going to look at is we're going to look at how the element will scale when the device is rotated. So if we just rotate this window here by clicking on this arrow here, and you can rotate it back and forth, you see that the object stays in the same top left position and doesn't change its width. This is because the auto sizing here was told not to anchor on the right or change or stretch its width. So what I want this particular element to do is when the window is resized, I want the width to stretch and I want it to stay in the same upper and left and right position. So I want it to lock on the sides in the top, but also stretch. So we do this by locking it to the left and right and the top, so it stays in the same top position, and then I want it to stretch. So now if we change the width, you'll see that it will stay with the same amount of gap on the left and right and the top, and it will stretch to fill the new width, and it will go back again. So bring in another object here. I'm going to bring in a button, which we'll use to change the text on the UI label in the application. So this button here, I want it not to stretch. I just want it to stay in the same position that it is. Now, what I do to that is I would not select a left or right anchor. I just say I want it to stay in the same vertical position. So doing this, the button will stay in the same vertical position, but when the layout changes its width, it will not lock to any particular side. So I'll show you what would happen if I actually locked it to one side. So when it rotates, you can see that this button has been locked or anchored to this side and also the top. So it's stayed in the same vertical and right position when it has been resized. But if I say, hey, I only want you to lock to the top, it should stay in the center like it has there. And then in this pane, there's also a few other handy tools. So if you want to automatically align things in the center and all of that, you can use these buttons here. They're pretty self-explanatory. It's worth having a look at different configurations of these options here. Again, I personally think of these around the outside as anchors. So you anchor the particular object to any of these sides or multiple of these sides, and that there's stretching in the middle here. So how it stretches, whether it stretches horizontally or vertically or both. So if I say to this one here, I want it to stretch horizontally, vertically, and lock to the left and right, when it changes, it should get slightly thinner because the height in the landscape mode changes. So that's how you handle auto sizing for particular UI objects. Now I'm just going to change the disabled state of this. So when it's disabled, the text will be red. Okay, moving on to the next section, we are going to finally link these objects up with our applications. We're going to create an IB action and an IB outlet. An IB outlet is how our application can communicate to this UI label here, and an IB action is how this button, when pressed, will communicate back to our application. Okay, so I'm just going to go into my main UI view controller here and go to the header file for it. And I'm just going to define an IB outlet for the UI label. And now to create the IB action method for the button. So just recapping what I've done there, I have told Interface Builder that this object here is available to be used as an outlet. So when Interface Builder, I'll tell it in a minute to reload the class files, it will look at this file here and say, okay, are there any UI objects that I can use as an outlet? So any objects that I can link back to the application. And telling this here and stating this here will tell Interface Builder that this particular object is available and its type. And then we have an IB action here, the same again. It's a kind of a flag for Interface Builder. It says that we have an action here that you can bind to, so it'll bind any particular action on any object to this button pressed method here. And any IB action always has a sender. This is the only and first argument. It will be the memory ID of the particular UI object that has called this method. So when the button is pressed, the button will be sent as this attribute here. It'll be sent as its memory address or its memory ID, which we'll go into in just a little bit. Okay, so now I'm just going to go into the implementation, or the M file. I'm just going to implement what I have done in the header file. Okay, so I've created the IB action method here. I've just put an NS log just to say button press. So when we press the button, it'll say it's been pressed. And what I'll also do here is output the ID so you can see it. So I know that an ID object will be an integer. So I'm just going to echo that out there. Okay, so that is the implementation file and that's the header file. Now I'm going to go back to Interface Builder and I'm going to say reload class files. What this will do is, because the files owner here has been set as Hello Interface Builder View Controller, which is this here, Hello Interface Builder View Controller, it will then go to this class and look at all the IB outlets and IB actions available and then display them in the connections window, which I will just bring up in just a moment. So reload the class files. So it's going to reload these files here. So now when I click on Files Owner, we'll see that we have a MyText IB outlet and also a button pressed IB actions. So I'm just going to link up by clicking on this circle here and going to the label. You can also do the same by clicking on Files Owner, holding down the control button and dragging that blue box over label, selecting MyText. So that's now linked up. It has now associated this UI label with the MyText the MyText IB outlet. And on the button, since it is an action that's in the inverse direction, we need to go from the button to the file owner and set the event as button pressed. So you'll see here now in this connections window here, we have MyText is now linked to the label and the button pressed action is now linked to the round direct button. It's worth noting that you have to do it in that particular order, so it goes from files owner to an outlet and from the object to the files owner if it's an action. Obviously, the action contacts the files owner and the files owner contacts the object in the UI view. Might be a little bit strange at first, but it makes sense down the track. Okay, so I'm just going to save that out, and we've now linked all that up, so that's all done in Interface Builder there. Okay, back in our application, we've got everything set up, so I'm just going to build and run. I'll just make sure I'm in the right simulator first. You'll have to excuse the simulator, it's not working out at its best at the moment, but here's our application, and if I press the button, I'll just bring up the console before I do that. So here's the console, nothing in it, and if I press it, it says button pressed and the sender, and this is that ID I was talking about. This is the address in memory of the object that called it. So what we can do here nothing very technical, we can actually say that sender set enabled no. So now running that, when we hit press me, you'll see that it turns red and I won't be able to click it again. As you can see, sender, the attribute, has been the UI button that pressed it. So that's what sender is. And so to add to that, what I'm going to do is I'm going to go to the UI label, so my text, set text, so when the button is pressed, we want to change the text on the label and we want to disable the button. So if I press it now, you see that mobile touch rules, and indeed it does. We won't be able to press the button again because it's been disabled, so you won't see any more button press messages show up in the console here. It will need to be set enabled yes for it to be able to be called again. Now you also notice in the simulator that when I tell it to rotate, it actually won't rotate. This is because in the UI view controller, as I was talking before in Interface Builder, we have UI view controller here. This file here is actually already a UI view controller. And in the UI view controller, we have a method here, which has been commented out, which has a comment of override to allow orientations other than the default portrait orientation. It's exactly what we're going to do. So I'm just going to uncomment these lines here. And what this statement tells us here, that should auto-rotate interface orientation, it'll return the orientation that the device wants to change to. And if the interface orientation is equal to a portrait orientation, then it will return true. We want to support all orientations, so I'm just going to say yes. As it says here, return yes for supported orientations, so I'm just going to say every orientation is correct. So run that back out again. And if we rotate the view, we'll now see that the label, although we can't see the bounds of the label, it is actually expanded to fit that space, and the button has stayed in the center at its current size. So if I press it, it disables the button and changes the label at the top. So that's how you link up Interface Builder with your Xcode project, by linking views and objects with IB outlets and actions. What I'd like to do now is actually show you what the zib we were working on actually looks like. So I'm going to open it as source code. And you'll see in this window here that it actually looks very familiar. Indeed, it should, because it's actually an XML document. And this XML document has actually been created by a class in the iOS SDK as well as the macOS SDK called NSArchiver. What NSArchiver does is it turns objects within your code, so let's say an NS dictionary, an NS array, it turns that back out to an archive format like an XML document or a binary file format into a file format that actually it can archive and unarchive, hence NS unarchive class. So what we're looking at here is the actual zip file for the one we just created. So if I just thumb through it here, we'll get to this section here where it has a UI view, and then it has a sub-object of a label with the default value of hello world, having all the text color arguments there, and then an IB button with all its particular options right there. So that's how zibs turn back into interfaces. They are encoded out using NSArchiver into XML, and then when the application runs, it will be turned from XML back into an interface. And indeed, some people think this can be slightly taxing on the system. It comes down to people's opinions and particular applications, but some people think that this is actually the long way of doing things, although it is thoroughly supported by Apple, and indeed Apple do use Interface Builder. But there is another way to build applications, And it's not that hard to do, although it's not the first thing you would do to build applications. You can build applications without zibs whatsoever by creating the objects in your classes and controllers yourself by hand in code. So as an example, I'm going to build this exact same interface, but without using a zib. And here's the difference. All this code here has been created without the use of a zib. And as you can see, I've actually deleted the Hello Interface Builder View Controller zib from the application entirely. And looking at the file now, you will see that I have implemented this init with nibname method at the top here, added in the text field programmatically and the button as well. I still have the button press. Instead of an IB action, it's now just a void statement. If you look at the header file, it's not that different. I've just put them in there as just normal properties. So what you're looking at here is the whole entire interface builder process put out into code. So we are initializing a new UI label object, and then we are setting the text as hello world. We are setting the text color. I've just generated that from using a program I have, and then we are setting UI font. I've just told bold system font of size 18, text alignment center, and then the auto resizing mask. This was a little tricky. I told it that it has a flexible width and it auto resizes with a flexible bottom, so it won't care what the bottom side of it does. It is not opaque, so it is transparent, and I've just set the background color to be transparent, a clear color. Then we have created a new button. I'm actually using a helper method here. Instead of using an alloc method, UI button has a helper method to create a button with a particular type. This does the allocation and initializing for you. I just have to set the frame. The frame here is the X, Y, width and height coordinates. That's X, Y, width and height. Same for up here. And I've told it that the auto resizing mask has flexible bottom margin, right margin, and flexible left margin. So it only anchors to the top. Title of press me on control state normal, and then I've told it the color, the text color has to change to red, which is this here, when it's been disabled. And then I've told it that when the UI control event touchdown is called, that it calls the button press action on the current class. Then I've added those sub-views to the interface. Then here is the buttons pressed method, and I've just changed that to zibless programming rules. So now if I run this, we'll see that we have the same interface, and if I press it, it disables itself, and zibless programming rules. So, although this is something you probably won't get to until you're very comfortable with iOS development, it is definitely good to know that there is a future beyond Interface Builder. And if you find things just aren't working with Interface Builder, or you find it's slowing down your production, maybe going to zibless programming is the way for you to go forward. Okay, so that about wraps it up for this video screencast lesson. I hope you've enjoyed it, and I've covered some new things under Interface Builder. So coming out next week is Mark Hammonds with Xcode Fundamentals, showing you more around Xcode itself and all the functions and applications available at your fingertips, as well as hopefully some keyboard shortcuts as well. They're very handy. And then the week after that, I will be joining you again for understanding Windows, UI views, and view controllers. So extending what I was talking about earlier with view controllers in Interface Builder. And then data persistent options, so talking about storing data in your application, and then many more lessons after that. So I hope you stick around to learn a lot more about iOS development. And as always, if you have any questions or comments, please leave them on the article corresponding to this video tutorial. I hope you have enjoyed it, and Mark will see you next week. Thanks for watching.